Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today we're with the Matrix Power Supply. Matrix has been very nice. They've sent me out several things. This LCR meter is just kick butt LCR meter. I've got this power supply over here, and I have this little power supply down here. We're going to open this guy up. We're going to take a look inside and see what it looks like. It's heavy. So unlike these other power supplies, this one feels like it's not a switching power supply. It feels like it's a linear power supply in here. So what I mean by linear is it's a low frequency switcher, meaning 60 hertz going through a transformer, dropping the voltage down. That's the low frequency switching aspect. And then it regulates the output voltages. So that's the linear aspect, right? So anyway, we're going to take a look inside this to see if that's true. I'm pretty sure it is. And we want to see the build quality, all that kind of stuff. So I think now this comes in a form factor like the Keithley and a lot of other things you see here on the bench. This is a standard form factor. The height is a little different. This power supply, like this Matrix, is very similar specs, but this one's programmable. That one's kind of a digital. It looks like analog like this GW, but it's, you know, it's a push button. You get to select what digit you want to change. This one has a really nice fluorescent display. So this is more high end. You know, this is a very nice, very high level. I can tell just by looking at it. This is a high quality power supply. Power supplies are generally pretty expensive. But with these brands that we're looking at, they're not like some of the lower cost Chinese brands you might see around. These are like the next level up, okay? So they've gone to the, basically essentially what they're doing, what it looks like to me, is they're giving you a high quality instrument in a relatively low cost factor. So maybe it's not $100, you know, like the lower cost things. Maybe it's, you know, more like say $300 or $400, but that's still, you know, a fraction of the price you'd pay from an Agilent, Keysight or something like that, some other name brand equipment, right? So let's open this guy up. Let's take a look. We'll look at the output voltages and stuff like that, see how quiet and how low noise they are. This thing is capable of, I think it's 32 volts. We have two channels, 32 volts. So you go plus or minus 32 volts if you want to use it that way. Let's say you're doing audio amplifiers. And then you have a third channel that is, sometimes they're solid 5 volts, you know, a fixed 5 volts, say 3 amps. You'll see some 3-channel power supplies labeled that way. This one, the third channel, is actually settable. It goes up to 6.2, I believe. And all the channels will do 3.2 amps out, which is kind of interesting. But so yeah, this one, and that's essentially the same thing as the Matrix up here, but up here it's not programmable like this one is. Okay, you can see all the buttons here. So let's take a closer look inside, and then let's play with it a little bit and see how it operates. All right. Oh, hey guys, and by the way, if you like this kind of stuff, give me comments down below what you like to see tested on a power supply, what you like to see in a power supply review, and give a thumbs up to the video if you like it. That really does help the channel. It's a free way to support the channel. Another way is to hit the super thank you button down below where you can buy me a cup of coffee, you know, that kind of thing, and or become a Patreon. Links down below, as little as $1 a month. Or you can become a member of the channel. That link's down below too. So you'll see that, yeah, by the super thank you button, I think, to become a member. I think I only have like 3 or 4 members right now. I had 4. I think I'm down to 3. It went up to 4, down to 4. I don't know. I think I got 3. So, yep, glad to have you aboard. All right, hey, let's jump into this video. Alright guys, so as far as build quality goes, I mean, if it's heavy, that's why I think it's, you know, a linear type power supply. And it has these large rubber feet on the bottom, so that's nice. Metal bottom. It has a switching 110, 220 switch right here on the bottom. Interesting. So Matrix Technology sticker there. Looks like a couple quality control type stickers here. And looks like here's the screws to take off the top. But I'm thinking it's gonna, I loosen this, it's gonna slide out the back, but this would be in the way. So I think I have to remove that first. So there's the front of this thing. Nice, nice banana jacks on this thing. It has really nice buttons, silicone type rubber buttons or whatever they are. But yeah, it's a nice, everything's really seems like nice quality on the output, okay? Now, one thing I want to point out is, see the screws right here? I think this is for the ears. So if you were going to put a 19-inch rack, there'd be some ears available for that. But these are the handles here where you pull out and you rotate it. So right now they're put down, which is fine for what we're doing. And there's the back of it. So we have our fan, RS-232, USB. USB is kind of common these days. RS-232 is kind of a hangover, but people still seem to use that in higher end equipment. So it has the IEC with the fuse compartment down here, and then it has the jumper box, which actually has the sense wires, the plus sense tied to the plus. So if you wanted to send out a sense wire, the power out to your whatever your load is, and make sure the voltage is regulated right at the load, then you could do that by disconnecting these and having sense wires go out to the load. So it's got all for all three, actually. That's pretty nice touch. So I think I'm gonna have to take off this back plate first, pretty sure, before I can do the the bottom. So we're gonna go ahead and do that. All right. Yep, that's right. So that just takes that off. So now I think we just take off the bottom and it'll slide right off, okay? And part of the reason they're designed this way is that when you do those ears or whatever, you can take off the front and back front plates if you want. And then the ears, I think, when they go in rack mount type, setups, people do that for testing purposes. So they can put them in automatic test racks. And, so you only do that when you have something that's a little bit higher end. All right, so just 4 screws there. Uh-oh, you know what? I feel like these handles are going to have to come off to have that thing slide out. So I'm not sure how to do that. Okay, there we go. We just have to, if I pull it straight down, then it was keyed so that I could pull these off. Okay, so that handle came off that way. Okay, so yeah, it was set on a key. So you have to have it straight down before it comes off. Probably straight up either. So either way. So let's go ahead and slide it out. All right, I see it like a little lip right here, little metal thing here. So kind of keeping it from sliding out too easy. So you have to get it where this guy can slide over the top. There we go. So, oh yeah, okay. I'm seeing inside this thing. Okay, so that's how that works. That little lip thing right there, that feature keeps it from sliding out on its own. And there's one in front too. That kind of locks this thing in place, okay? It's pretty heavy metal. You got the fins on the side for airflow, okay? So you got the fan in back, and well, here, let me show you this. All right, look at that. So look at this heat sink structure. There's 2 heat sinks. Looks like they're face to face. You got a fan here, fan here. So one's sucking and one's blowing, and it's coming off the sides here. So, honestly, I haven't seen it really. I'm not sure which way the fans are sucking or blowing. So, here, I can go ahead and turn it on. Except for I think it has to heat up before the fans kick on. So we'll check that out later, okay? So anyway, this is like heat tunnel, and it's pointing air this way. So look at this big toroidal transformer. Isn't that beautiful? That's nice. So it has a rubber thing here between this metal clamp and the transformer. So this rubber lip protects the windings, and that metal thing holds this transformer down. So that's a nice size transformer. It's right up front and it's right in the middle, so it keeps the balance nice. So that's a nice touch. You can see the circuit board on the front. There's a buzzer right here by my thumb down there. There's a large chip down on the board, another large chip right there. So that's to run all the controls on the front end. Now, if you look right in here, underneath these wires, you can see those wires there, and those shunts. I think that's meant for current sensing. And there's 3 of them, 1 for each channel. And I can see some through-hole resistors standing on their side down, or on their end down here in the corner. They look like maybe 3-watt resistors, so that might be part of it. But so we have the board up here. We have the board up here across the front, obviously. There's also a board here where this connector, the cable, is coming into. And then there's another cable off that same board coming down to this board here with all these current senses. And it looks like there's kind of a motherboard down below. Okay, so we have this board here on top. And man, there's a lot going on here. So we have this board, down below, that board, and that board. So it looks like 4, with the on the front end, this board and that board, and these 2 boards. Looks like there's at least 4 boards in this build. Let's take a closer look at this thing. All right, guys, so we have the huge toroid transformer. Down here, you can see the little jumpers. I think for current sensors, 3 of them. And a few big, the green 3-watt resistors down in there. So, and then we have the connector that goes up to the front, this board right here. See this little board? There's one down there, and then there's this connector with this cable that comes from back here, okay? So we also have another connector right here that comes up here and drops down to, okay, it comes up across here and all the way back. So it comes from here, okay? Then we have the ribbon cable, which goes down to that board, all right? So then we have this board, and you can maybe see all the, chips, the crystal here. A lot of stuff going on this board, okay? So I removed these screws, 2 of them, off of the RS-232 connector over here. See it protruding? So now I can pull it out. So let's carefully pull this out. I started to pull it out, and I could see right away that there's this little metallic part of this guy that has to come off, okay? So that's just part of the USB connector. Part of the RS-232. So now let's see what I have to do to get this out of the way. Maybe I can just turn it. Oh, I just turned it over. Okay, I see a whole bunch of relays down there. See these relays? There's 3 of them right there. And there's 3 of them over here. Man, there's a bunch of them. And then there's some big aluminum electrolytics. One right here. And one over there. So, man. And then a bunch of capacitors down here. Another relay right there. Now, see from the front panel, this little extender, that's the on-off switch right there. The mechanical on-off. Right up here where the AC power comes in. And you can see the ground wire immediately goes to the chassis, which it should. Okay, so the chassis is tied to ground, earth ground, right? What we call earth ground. And yeah, so there's all the input stuff. So, man, for sure, it's a big linear power supply, big old transformer. And we got a lot of cooling here. There's got, oh, here we go. Let me pull it this way. You can see the devices mounted against the heatsink there, right? So looks like maybe a bridge rectifier, maybe another one. It looks like 1, 2, 3 bridge rectifiers and a big old transistor. So that's interesting. It must be for the 3 different outputs. Each have a bridge rectifier coming off. You know, see this transformer? All these wires. Some of them are primary windings and some are secondaries. But guys, see how many there are? So I think the smaller wires must be the primaries coming in. The big wires on the output here must be the output. But that must be, you know, for the 3 different channels. So my guess would be this is 5 volts and that's a plus minus 30 volts. Well, 6.2 plus minus 30.2. Let's look on this other side down here. Oh yeah. See down there? All the transistors. So that's all the transistors for voltage regulation. So that's one heatsink. You can see the kind of divider here. So there's a bunch of fins, and these fans are blowing across both these fins, you know. So these 2 fans are working good to keep everything cool. So, yeah, this, and here's a buzzer right up here on the front panel. So, yeah, I'm really enjoying the design of this because it looks really solid. Let's look on the back side. Okay, it looks like all the parts are on one side except for this guy. And the connectors down here for the USB. Here's a USB and the RS-232. So, wow. But man, look at all those chips right there. So this metal thing that goes on the RS-232, that's just a metal jacket that goes on this plastic thing. Why would that be there? I think it is part of the shielding. So there's a solder joint here, solder joint here, and this must be the other side where they're trying to keep some kind of shielding. All right, guys, I just wanted to point out some of the neat things. You know, they use this red Loctite or whatever to keep the cables secure. So you can see that there. That's a nice touch. And then also the board, the layout, the design of the board looks very nice, very neat. And here it's a version 3, so it's not a brand new version, 2021-0706. And so, yeah, 100 XT. I mean, so that's the data on the board right there. It's very, you know, everything looks very clean. The cable management looks very nice, like all tight, you know, tied off about every inch or so. And, you know, it's just, I mean, it looks very clean, right? More red, you know, you see the red on all the connectors, you know, down in there, you see it as well. You see this nice insulation, kind of a rubberized feel to it. It's probably a nylon with a rubberized feel that's keeping these things so they don't get abraded. They're not just hanging out. And they're managed nicely with another tie right here. So, yeah, just a lot of attention to detail. Looks like it's done very nicely. The whole heatsink design with the dual fan setup is really cool. Literally. Alright, guys, so the chipset's down here. A little bit hard to see, trying to focus in on them. But looks like a nice design on the front panel. The buzzer, the connector, just trying to get a little bit closer up, look at some of the parts on the thing. You can see the current sense resistors. Alright guys, so I just want to give you a little closer look up of the parts here on the board and just show you the quality, the craftsmanship it looks to me like, you know, that they've done here. Alright guys, so first of all, let's peel this off to display that beautiful display. Do I pull this knob off? How do I do that? Okay, there we go. That worked. All right, look at that nice display. I hope it looks as good on camera. So 32, 32, 6.2, all 3.2 amps. So that's the way it looks before you try to set things up. You got a voltage set. You can set here, and the arrows on this first channel. So if we just, I can push the buttons to control which digit I want to control. So I can make it say 12 volts if I want, 12.5. Move it over here. So I can do it that way, or I can say 12.6 and then enter. Whoops. There we go, 12.6 enter. So there's that, and then I can say, oh, but you know what? I want to make sure my current doesn't go over 1 amp because I don't want to damage anything. So I can go 1, enter. So now that's set up. Okay, then I can say, oh, okay, this guy is going to be 15 volts. So, okay, so then I come over here and I hit this right here where it says channel. And I go channel 2 and I go 15, enter. Whoops, how come it didn't do it? Oh, we're on current still. So let's go voltage, 15, enter. And then current, I'm going to say 0.5 amps. So current, 0.5. All right, so those things are set up. And this guy's going to be 5.1 volts. So let's go over here. And we're still on voltage, I think. So 5. Nope, we're on current. The arrow is on, it just points at the thing, but I have to say voltage. So 5.1, enter. And then current, we're going to say 2.5 amps. So we'll go current set, 2.5, enter. All right, so now let's say I have my leads all set up, ready to go, channel 1, 2, and 3. So then I just hit on off. And it's trying to put out those voltages, no current. So it's monitoring what's happening at the output. And then I can say, okay, let's turn it off. So I love being able to turn on, and you can you hear those relays? I love being able to turn on and off my output that way, where you can turn on the power supply, set up everything, and then say, okay, go. Now there's also OVP here. I think if I go shift OVP, then I can set up things to say, if for some reason the voltage spikes up above a certain voltage, I can have it, protect that and not do that. So, so that's how you can do that. You're going to go ESC, and we have a menu. Let's go shift menu. Haven't done this yet. Okay, system. Let's hit enter. Okay, out state, out parameter. So there's a lot, and then knob. So there's a lot of different things. I guess I can go over this way. And is that how? Okay, what if I hit enter? Unlock, lock. Okay, so you can lock things so that you can't accidentally change something. So that's cool. Okay, let's go escape. We go back one menu. Output parameter. Let's hit enter. Reset keep. Okay, so you know what? Let's just hit reset and see what happens. So enter that. Okay, out state. Let's go look at that thing. Okay, off and on. Okay, so all right, cool. So let's hit escape again, and let's go to configure. Enter. Channel 1. Enter. Max volt, and then output timer, so we can start programming things. Okay, I'm gonna escape out of that, and let's go to COMB. What's that? Okay, so independent series or parallel. So if I want to put channel 1 and 2 in series, so instead of 32 volts, I can get 64 volts. I can do that. So I can say, right now it's independent. I'm going to say series, enter that. Series set success. Okay, so now channel 1's 5, channel 2 is 1 plus 2, and channel 3 is still 5.1. So so now that's set up. So let's go back into the menu, shift menu, and config. Let's say we're going to go, whoops. Okay, let's go to this combine one again. And this time, let's go to parallel. Success. Okay, so now channel 1 and channel 2 are in parallel. So now I still can only go up to 30 volts, so 30.2. But now I can get, instead of 3.2 amps on each one, I can get 6.4. So now I can go higher. So yeah, that's pretty neat that you can set up this thing for series parallel, and it just makes it really easy. So by the way, channel 2 would be the combination. So I'd come here for the combination parallel. Okay. Let's see. Let's go to menu again. And we're going to go back to combine because we're going to go back to independent. Oh, and then there's tracking. So you can set up a tracking output. Tracking success. So now I can set one and the other one should track it. So that's how you get a plus minus supply. That's kind of cool. Okay. So let's go shift menu. And come back to combine, whoops, combine, enter, and we'll go back to dependent. There we go, back to channel 1, 2, and 3. And it remembered the settings I had as well. Alright guys, I just wanted to kind of show you this display by kind of explain this one by this one. This one's like a 7 segments. So that 0 has, if you count them, there's 1 segment on the bottom that's lit up, 1 on top that's lit up, that's 2. Then there's 2 on the sides, that's 3, 4. And then 2 more, 5, 6. And then if you had an 8, that one in the middle would be lit up like this. So 7 segments, okay? Where this one's like a dot matrix, right? You have a matrix, you have a whole bunch of little dots. And so, yeah, it's just a different way of doing things. But this is kind of like that fluorescent display. So, yeah, just kind of a cool display, right? Nice, bright display. I really like this display. So, just wanted to point out the difference between a 7 segment and this matrix type of display. Hey guys, so what do you think of this power supply so far? We've looked at the inside, we've kind of looked to see the operational, you know, how the knobs work, so on. The next thing to do is, you know, take this thing for a ride, see how it works, right? You know, step load it, look at the output with an oscilloscope to see how clean it is. So being, you know, the low frequency switcher, the old-fashioned transform big toroid with the linear output, it's a linear power supply, so it should be very clean. It's going to be nice to have that to test it against some of these switching power supplies. So what do you guys think? What kind of test should I do? What do you want to see? Now, these things are great for audio amplifiers where you need a plus minus voltage rail. Maybe you need a 5 volts for, you know, something else. Anyway, these triple output power supplies, I always kind of thought it was funny because they just throw a 5 volt with a fixed 1 amp or something called a triple power supply. I'm like, instead of a, you know, tracking or whatever kind of power supply, they came out with this triple power supply thing. But this one truly is, I mean, a variable output for the third output. So that's, I think, a little bit more usable. The current's nice and high. Now the current on this Tektronix, this one's actually similar. It goes up to 6 volts. It actually goes up to 3 amps or 5 amps. So that, but the other two, the plus minus, you know, the channel 1, channel 2 only go to 20 volts and 2.5 amps. So not near as useful. The GWN stick, who actually makes this Tektronix, they go to 3 amps and 30 volts on each one, but this is a fixed 5 volt and 3 amps, so you can't even set the current, okay? I'm not sure if you can set the current on this one or if it's a fixed 5 amps. I think it's fixed, but I'm not sure. Got to remember, because it has got a lot of programmability on it. And this one up here, the channel 3, I think it's a 5 volt fixed 3 amp, so they're both fixed. It's nice to be able to reduce the current in case you're, using something that only takes, say, a half an amp. If there's a problem, you don't want 3 amps going through it, 5 amps going through it, because it just burns up the whatever the problem is and might burn traces off the board and stuff. So it's nice to limit the current, especially the first time you power things up or when you're developing things and you're troubleshooting. It's nice to be able to limit current on things. So I got an HP back here, which, you know what, guys, I think I'm gonna put that one up for sale along with some other stuff. I gotta clean off this bench, redesign it, right? Hey, 2 big thumbs up to my patrons. Really appreciate you guys. Really appreciate you guys that are my members. 2 big thumbs up to you guys. All 3 of you, or 4 of you, whatever there is. Thanks so much. There's a super thank you button down below. Just to remind you guys of that. You can become a patron for as little as $1 a month if you like. And meanwhile, we're going to try to pump out a bunch of videos in the next week, okay? All right, thanks guys for watching, and let me know what you'd like to see tested on this thing to really take it through its paces, okay? Thanks for watching. See you next time.